What are two basic services provided by all cloud providers? Each correct answer presents a complete solution. What are two characteristics of the public cloud deployment model? Each correct answer presents a complete solution. What are two characteristics of a consumption-based model? Each correct answer presents a complete solution. Why is cloud computing often less expensive than on-premises data centers? Each correct answer presents a complete solution. What is an advantage of cloud computing compared to on-premises deployments? Answer choice refers to upfront costs incurred one time, such as hardware purchases. In cloud computing, answer choice allows you to deploy applications to regional data centers around the world. Increasing the capacity of an application by adding additional virtual machine is called answer choice. Which cloud service model provides you with the most control over the hardware that runs applications? Which Azure component allows you to replicate resources across a geography to ensure business continuity during a natural disaster at the primary site? Which resource can you use to manage access, policies, and compliance across multiple subscriptions? Which two Azure resources can make use of availability zones? Each correct answer presents a complete solution. What can you use to execute code in a serverless environment? You need to allow resources on two different Azure virtual networks to communicate with each other. What should you configure? Which storage service should you use to store thousands of files containing text and images? Which two features are available by using Azure Cost Management and Billing? Each correct answer presents a complete solution. Oh, you have an Azure virtual machine that is accessed only between 9 and 17 o'clock each day. What should you do to minimize costs but preserve the associated hard disks and data? Your organization plans to deploy several production virtual machines that will have consistent resource usage throughout the year. What can you use to minimize the costs of the virtual machines without reducing the functionality of the virtual machines? What can you use to ensure that new and existing Azure resources stay in compliance with corporate standards? Oh, you need to recommend a solution for Azure virtual machine deployments. The solution must enforce company standards on the virtual machines. What should you include in the recommendation? What allows you to orchestrate the deployment of resource templates, Azure policy assignments, and resource groups? Which management layer accepts requests from any Azure tool or API and enables you to create, update, and delete resources in an Azure account? Which two tools are accessible via Azure Cloud Shell and allows you to write bash scripts to manage an Azure environment? Which two tools can you use to create a new Azure virtual machine from a mobile device that runs Android? Each correct answer presents complete solution. What can you use to manage servers across cloud platforms and on-premises environments? You need to create a custom solution that uses thresholds to trigger auto-scaling functionality to scale an app up or down to meet user demand. What should you include in the solution? Which Azure service can generate an alert if virtual machine utilization is over 80% for 5 minutes?
And that's going to run the operating system. It's going to run the sensors. There are various starter kits available. There are Azure Sphere certified microcontroller units. And then this runs an operating system. So Azure Sphere then gives me the OS. It's a customized Linux kernel. But once again, it's something now that Microsoft is responsible for maintaining and updating. And then on top of this, Azure Sphere kind of has this A3 service. So this is the Azure Sphere Security Service. AS3, sorry, AS3 I should have said, AS3 Security Service. So that's making sure it's not been compromised by some malicious software. It's using certificate-based authentication to also authenticate to Azure. Because really, think about compromise. Compromise could be someone sending bad things to the device, but it could also be someone pretending they're the device, sending bad things into my data, which could make me do bad decisions. So it enables the secure communication by proving I am who I say I am to make sure there's not bad things coming in the other way either. So this is all about kind of that security. Moving on. So I talked about data, and I had kind of databases. But when I think about data services, there's actually a lot more than just storing the data. So if I think data service, think about the flow. There's some kind of source. These could be from the cloud, they could be on premises, all these different types of systems. It could be files, it could be database rows, it could be streams of data. And I want to basically get it to some sink. We talk about source to sink. Maybe that's a data warehouse, another database, other types of things. So this whole format we talk about where we have to extract the data, we have to transform the data, and we have to load the data. So say I have to be able to get the data out of that source system. Now what we will sometimes see is everyone talks about data lake. Data lake are these huge, huge stores. So this is the Azure Data Lake Storage Gen 2 that sits on top of Blob. Sometimes we will actually extract and actually do a load and then kind of carry on. The reason for this is historical, but it used to be we would transform it quickly because there wasn't much disk space. We had to only keep the data we needed to do our job. Today, there's lots of storage. Maybe in the future, I have different requirements. So by storing the data in its raw format, well, then later on I could come back to that and transform it in different ways to do the job I want. Now, when we think about all of these different stages, something has to orchestrate that. So all of that orchestration, enabling all these things to talk, calling the different connectors, that is Azure Data Factory. So that is basically the orchestration functionality. For the transformation, there are many different services. Now, the one you'll commonly hear about is HD Insight, which actually hooks into a whole bunch of multiple open source different services. There's things like Hadoop for disk-based processing. There's things like Storm for real-time processing. There's Spark. So Spark's a big one, mostly batch jobs, but it's kind of an in-memory set of capabilities. There's Kafka for big data streaming. There's Hive LLAP. There's HBase, all these different options. This is all about this transforming, getting the data, maybe removing duplicates. It's wrangling the data. It's getting it in some format that I can now do something useful with it. There's also Databricks. So if HD Insight is all about large numbers of different open source types of framework, this is all built on, so Azure Databricks is using Databricks, which is really built on Apache Spark. So it's a fully managed offering that I can use for the transformation of my data. So you may hear, hey, Databricks, fantastic for that. There's a whole analytics service around it. It uses VMs and blobs behind the scenes, and it's actually used by other types of service we have as well. Now you may also hear, so if that was Azure, let's write Azure there. So if that was Azure Data Factory, that full source to sink orchestration, you may also hear about Azure Synapse and analytics. And that really comprises of this and more. So it has its orchestration, it has a whole Synapse workspace. It used to be Azure SQL Data Warehouse, so it has a data warehousing capability, but it also has its own Apache Spark transformation service. The whole point of Azure Synapse Analytics is it brings everything together into one workspace. I'm not worrying about connectors between things, I'm not worrying about roles and permissions between things. It's really just doing everything for me. But it's using some of these other components behind the scenes, but it brings it into one workspace, so it really simplifies that whole thing. So that was data services. Then we get into things like AI services. So we talk about AI, artificial intelligence. We talk about AI and ML, so machine learning. So artificial intelligence is more about the deep learning based on the neural network of the mind. Machine learning is about training a model on some existing data so it can then apply that model to new data to maybe forecast future outcomes or to understand something it's hearing or seeing or many other types of things. And so there are various services built around AI. So I can think about Azure Machine Learning. This service is about me as a company. This is a platform for predictions. And what that means is I'm doing the work. So I'm going to do the definition of how to kind of get the data. I'm going to kind of create the models. I'm going to do the testing of the models. And then I'm going to kind of deploy the algorithm that I've created via an API. And this enables me to do that. So Azure Machine Learning is where I want to basically do the work. I have data scientists that want to work out where the data's coming from, create the various models. I want to train the model, evaluate the model, create a pipeline for the experiments, and then make that final model, that algorithm, usable via some API endpoint. So this is I'm creating something. What about if I don't want to do that? The next thing we have is Azure Cognitive Services. So what we get now are pre-built models based around a wide range of different types. There are things around language. So it can do things like, hey, I can have natural language coming in and it can actually understand it. It can evaluate sentiment. Is this positive? Is it negative? It can understand what users want. I can understand things like speech. So I can convert speech to text. I can translate from one language to another language. I can do various types of verification and validation. There are vision services. There's many different types of this. But I can, hey, I know what you're showing me. So that's a car, that's a bus, that's a person. Oh, that's John Saville, that's someone else. Oh, there's 5 of those things in there. So I can analyze pictures, analyze videos, or other types of visual content. And everything like decision services. So these are all pre-built. So the point of this is, hey, I don't want to build and train models. For the most part, I want to be able to just take some pre-built model and use it. So that's Azure Cognitive Services. Then we have the idea of Azure Bot Service. An Azure Bot Service, I'm going to try and draw a bot really quickly. Terrible picture, I know. Yeah, that's a robot. So the Azure Bot Service is really about the idea of interacting with people. Now, this could be a kind of a chat bot. It could be voice, because remember, I can integrate with other types of service so I can understand natural language. So the whole point of the Azure Bot Service is I want those kind of interactions with an actual human being. I'm going to build an entire knowledge base of things it knows and it can draw from how it can respond and answer to that person. I can have these nice interactive cards for nice visual interactions. And this single bot I create, I could link into many different types of channels to actually use that. So those are when we think about kind of those AI services. Now, let's come over here for a second. The next basic thing you need to understand is this idea of DevOps. Now, DevOps is not an Azure technology as such. But remember before we drew this idea of, hey, we had this Git repository where I stored a JSON file and we provisioned things to this. So DevOps is all about a process. It's the way people work together. It's the tooling process they may leverage. And there's different ways we enable that. You'll hear things like continuous integration, pipelines, continuous deployment, continuous delivery. So we have this idea of DevOps. And there's this whole cycle you kind of see in DevOps around, hey, we get feedback, and then we constantly make these small incremental units of business value. Then we gather more feedback, and we then enhance it some more. It's a never-ending loop. And there are different tooling sets available to us. So there's Azure DevOps. So Azure DevOps has repos. So as you would expect, it has repos, so it can be Git-based, or it has its own Team Foundation version control, which really no one is going to use anymore. Git really has become the standard in repos. This is how we can do that version control. That's all what repos are around. It has the idea of boards. So boards is about how we can organize and track projects. And Azure DevOps is very, very good at this. If we jump over for a second, I've kind of got a board that I use to track the videos I work on. So I can see, hey, this is my video planning board. And we have these Kanban boards, which is based on how we organize and move things. I can have these swim lanes and work in progress limits. It's a really great, powerful solution. So Azure DevOps is great for that. It also has pipelines. So pipelines are all about that idea of, well, continuous integration, continuous delivery, which is about constantly building our software, maybe continuous deployment, actually pushing it into production as well. And that's been a very rich solution for Azure DevOps. It has the idea of I can have gates between different stages, which could be different environments. And that's something that's really, really strong. It has artifacts where I can store kind of these built, maybe it's some library, something else. It has test plans. And while this is a very mature solution, it's really not getting a huge amount of investment today because Microsoft bought GitHub. And this is very much the future. And now where GitHub shines is repos. It obviously has repo functionality, but it has fantastic security. It can detect data secrets in there. It can convert your code to data to run algorithms to detect vulnerabilities in your code. There's a whole set of rich functionality. It is the open source kind of repo for the world. It also has actions. Now, its actions are, yes, it does CI/CD and else. Well, maybe all. Because it's not just restricted to CI/CD. With GitHub Actions, I can create an action off really anything. So if I was to go and look at my, this is my GitHub, I can create actions. And I can trigger off really anything I want. So I've got different workloads here. So one of these, for example, is you have a kind of an on. So these ons, I've got mine just set to nothing, so I will manually kind of run this. But I could trigger these on really anything. And what makes that so powerful is I could trigger it, hey, someone submits a pull request, someone joins a community, someone posts a comment. So these actions are super powerful. It has environments now, and I can have kind of gates on the environment. So I can still have those really nice controls now on GitHub as well. It does have the idea of projects, which would be like kind of the boards. It's not as rich today, but I expect it will catch up. And again, it has the places I can have like artifacts and all of those things as well. This is the future. Like, this is where everything is going to go. It will, the places where it's weaker today, like projects, it will catch up and pass. But if you had Azure DevOps today, great, you can carry on using it. If I was starting today, I would probably be going GitHub. And they can work together. I could have my repo for my code and use Azure pipelines or Azure boards to actually manage it. Then we have Dev Test Labs. Dev Test Labs is all about the idea that, hey, I need to create a bunch of VMs of different configurations so I can test something and then tear them all down. Well, I say VMs. The reality is anything I can define in an ARM template, I can define with this. So it's about creating environments for testing, doing the testing, and then tearing it down afterwards. Now, tearing it down afterwards is actually really important. Because Azure's consumption-based, remember. We pay for what we use. So let's dive into this a little bit. So let's dive into this idea of, okay, these are all the governance, and we talked about budgets and stuff like that. Let's go into, well, what actually costs us money? And what can we do to maybe optimize those costs? So how do I think about costs in Azure? Remember, fundamentally, we're often creating a resource. So what's going to define the cost? Well, there's a type of resource. Storage account, virtual machine, media service, machine learning, that type of resource will impact the cost. Then the type will often have a SKU. Is it a standard? Is it a premium? Is it a basic? Maybe there's a tier. Well, the tier, hot tier, cool tier, archive, that costs me money. Location. Different things may cost different amounts of money in different places. And then based on that, there may actually then be metering in place. Often there is, it's consumption-based. So I can then think about, okay, well, if that's the basic structure of the unit, well, does it exist? Is it provisioned? Is it running? Like a virtual machine, if it's not provisioned on a host, but it exists, I don't pay the compute charges. How many? We think of auto scale, remember. Virtual machine scale set can change the number we have. How much work is it doing? Think of serverless. I can think about, well, how much is it storing? If it's a database, if it's a storage account, that's going to impact. And that, when I think about the storing side, well, there might be, okay, so there's capacity. But then I can think about interactions, transactions. And that might go into what's the right tier that I should use. There might be licensing. So there's many, many factors that actually influences the cost of my resources. So I can think about what are the things I can do to help optimize that. Okay, well, how many? Auto scale. Make sure we're only running the number we need for it to work. Make sure we optimize the SKU. Remember those VMs, they're ones that memory optimized, compute optimized, general purpose. Make sure the ratio of resources is matching the workload so I don't have a bunch of wasted resource that I could do something better. Make sure we deallocate when it's not required. There are ways that you can automatically shut down VMs at night. So if I have like a dev test environment, we'll shut it down at the weekend, shut it down when people aren't using it. I mean, that's essentially what autoscale does. But also, does it exist? Am I paying for something that doesn't exist anymore? So make sure you use resource groups to organize, and then you can actually delete things more easily once a certain project is no longer required. If there are tiers available, can I use that kind of lifecycle management to move things around? So I'm optimizing capacity costs against those kind of transaction costs. And the type. Ideally, I want to be moving from IaaS to PaaS. That includes both compute and database. I don't want to run a database in a VM if ideally I could probably run it as a database PaaS service. Azure Managed Postgres, Azure Managed MySQL, Azure SQL Database, Cosmos DB. That's much better than running those products in a virtual machine. There's probably going to cost me more, but it's also far much more work for me to actually be managing. Make sure I can always identify the owner. So if all of these, remember like the metadata, well, make sure on these things I have tags. Because I want to know who the owner is, so I can always say, well, whose is this? Are you still using it, or can I delete this thing? So you want to be able to optimize those things. And in general, there's a thing called Azure Advisor. We're going to talk about this. Azure Advisor gives me kind of guidance over a wide range of areas, but it gives me recommendations about cost. So I want to be looking at that frequently, maybe once a week, to get ideas if there's something I could be doing. Now, outside of these general cost-saving things, there are other things that I can do. One of them is something called Azure Reservations. If you imagine I pay a certain amount of money based on the SKU and the number I have running, over a certain amount of time for a certain type of resource, my usage may fluctuate a little bit. I'm talking about maybe over years, there's seasonality. But there's kind of this base level, but I'm always using that amount. Azure Reservations let me, for kind of 1 or 3 year terms, say, hey, I'm going to use this type of resource, could be storage or Cosmos or a particular SKU of VM. And if I commit to using it for, let's say, 3 years and this amount, you get a massive discount. So those can really help me save a lot of money if I can commit to using that for a certain amount of time. The other things I can do is, remember this licensing. So there's something called hybrid use benefit. And this is all about the idea, well, I have some licensing already. Maybe it's the OS like Windows or even some of the Linux or things like SQL. I've already got the licensing covered by an enterprise, an EA agreement with software assurance. Hey, I can bring that and use it against resources in Azure and stop paying for the licensing part. I'll use my existing license, basically bringing my own license to it. I might have workloads where I need to get work done, but it's not time critical, and it can be resumed. So it can get stopped and it can start again, kind of this existing idea. So one of the features we have is Azure Spot VMs. And what this lets me do is, remember we talked about the cloud and it was limitless because there's this massive amount of resource available. Well, obviously they have servers, but they have to have a huge amount spare for when people suddenly create 1,000 cores or something. Well, I don't really want empty servers if they can help it. So what Spot VMs let me do is I can say, hey, look, I want to create some VMs, but you know what? I'm okay if you have to stop them because someone who's willing to pay regular pay as you go needs it more than me. So when I create certain types of resource, what we'll actually see is this idea of, let me change the SKU. We'll see this idea of Azure Spot instance. And if I say yes, I can actually go and look. And what it's going to do is I can set a price. I'm willing to pay up to a certain amount of money, or I'm willing to pay up to its regular rate, but I will still get taken off if some regular on-demand customer needs it. And what it's basically showing me here is what price I currently pay, and what is the chance of me being evicted by regular pay-as-you-go customers. So the rate's going to vary. Obviously, typically, if they have so much spare capacity, they'll charge you less because they just want to try and get it used. The less spare they have, the spot price may go up. I can see over here, for example, like Canada Central, well, it's really cheap, and eviction rate is 5 to 10%. So I can see I can get much, much cheaper resource, and this will be a great fit if the particular resource I'm creating is running some workload that it can be stopped and then resumed again. Obviously, I don't want to lose all my progress. So it's some job I'm running that, you know what, it can be stopped because I can just resume from where it got to. It's some maybe batch process or something else. So it's a way I can use all that huge capacity and get it as cheap as possible. Now, when I think about all of this, when I think about costs, how do I know what my costs are? So there is